So, what is your favorite park, garden, or outdoor space to spend time at? Anybody got an answer for that one? What's a good park around here? Swanee? Okay. Anything else? Is there a Peachtree Park? Yeah. Okay. Sweetwater? Okay. So I live on like the other side of the county, so like I don't know any places over here. So, that's cool. Okay. All right, so today we're going to use mathematical reasoning to model a real-world quadratic relationship. So you've got a school garden task. You are tasked by the principal of your school to create a school garden. You are given a rectangular outdoor space with an area of 192 square feet that also has a perimeter of 56 feet. What do you remember about area and perimeter? What do you always tell me that perimeter is? You're adding all the sides, and then area is what? Multiplying length times width, right? Okay, good. All right, so your challenge, what are the largest possible length and width of the garden given the various restrictions? I want you to take a moment and kind of think through this. So you have to have an area of 192, but it has to have a perimeter of 56. Okay, so go ahead and do part 1. Go ahead and do part 1. So what'd you come up with? Good talk. 12 times 16. Okay, so 12 times 16 gives me what? That gives me 192. And then if I add 12 plus 12 plus 16 plus 16, what does that give me? Gives me 56. Can anybody beat those dimensions? Like you got something bigger than 12 or 16? No. Okay, how did you go about doing that one? Yeah. I like okay, so you said 192, what are factors, right? Okay, another way you probably could have done this. I'm a big fan of Desmos because it does all my work for me. Okay, so if I do 192 and divided it by x and go into my little table and I continue adding numbers on here, then I can kind of check them. Okay, notice how these numbers, they get big and then they start coming back down, right? Yeah. Okay, so 12 and 16 are probably the biggest dimensions. We could also do like 8 and 24, but let's see if we can add that together to give us 56. 24 plus 24 plus 8 plus 8. That doesn't work. That's over 56, right? Okay. What about 6 plus 32 plus 6 plus 32? Okay, again, too big, right? Okay. Where's my slides? There they are. Okay. All right. Let's look at part 2. After presenting the dimensions of the garden to the principal shares with you a few restrictions. The school can only purchase enough dirt to fill 60 square feet for a garden. There must be a uniform walkway around the entire garden for access. Assuming the entire area is still being used for the garden and the walkway, what are the new dimensions? Okay, so you just told me that the dimensions were 16 and 12, right? Can't write today. 16 and 12. Okay, now you're having to take into consideration, instead of it just being this, there's going to be a walkway that goes all the way around. Yeah. So it does make it smaller. Okay, so looking at our dimensions, how does that impact this? See if you can like write an equation or figure out the dimensions for that one. There's always one like this on your final and on your EOC. There's always one like this. They like to ask questions about gardens. I don't get it, but it's fine. Okay, so do we know how big the walkway is? Like the length of it? No, we really don't know what the width is either, right? Okay. So if you wrote an equation, it would look something like this. We've got our dimension of 16 feet along here. And then we don't know this guy yet. So we're going to call him X, right? All right, I'll write this out. So we're going to call this guy X. Okay. Again, same thing over here. We don't know this guy, so we're going to call him X. We don't know this guy. We're going to assume these are X's. So when we actually write this out, now we want an area of 60. That's the new space. Okay. And then we've got 12, which is the whole thing, minus this, minus this. So minus 2X. We got the whole thing minus this and this. So that's where they're getting this formula from. Okay. Now we can solve, and as you can see right here, they have it listed as 3 feet. Okay. Because actually, if you graph this equation, the x-intercepts would be 3. Okay. And we're going to skip the swimming pool task. So I want us to use this kind of as a review on your mastery check on Friday. Okay. This is basically what it's going to ask you. It's going to ask you for the axis of symmetry. It's going to ask you for the x-intercept. It's going to ask you for the y-intercept, etc. Okay. So let's go ahead and take a look at that. We also can fill in this little table. So what are some points on this graph? Like, let's do this one first. What is this point? 1, 0. Okay, what's this point? What's this point? What's this point? This point. And this point. And this point. Okay. And notice how I filled in that table by just looking at the graph. Boom, there it is. Okay. Now, what are our x-intercepts? Where does it cross the x-axis? Okay, another way to look at this as well is which ones have a y value of 0? So what's our x values? 1 and 5. What's our y-intercepts? So what that means is our x's are 0. What's our y-intercept? 5. Everybody see it? It's a little light. Okay. So 5, 1, and 5. Cool, cool. All right. What is our vertex? What's our lowest or highest point? Not 5. It goes down, right? So are we going to have a minimum or maximum? We're going to have a minimum, and it's going to be right here. It's the lowest point. This is like that point on a roller coaster where it like you feel like your stomach just like fell to the bottom. Yeah. Okay, so 3, negative, oh, I'm sorry, 1, 2, 3, -4, right? Cool. What's our axis of symmetry? And how can we tell? Axis of symmetry is that line that goes straight down the middle, right? Okay, so where is it? It's right here. So at 3, so x equals 3. Notice how that's the same number from your vertex. You told me that it is a minimum. And what is our lowest minimum value? What's our y value that's the lowest? Okay. Good so far? Okay. Domain, for any quadratic, it's going to be from negative infinity to positive infinity. So from left to right, we can plug in any value. For range, we're going to say from minimum to maximum, right? So what's our minimum value? Okay, so from -4 to how high does it go? It keeps going on forever, right? Our in behavior, as x increases, what's happening to our y values? They're increasing. As x decreases, so as we move to the left, what's happening to our y values? Increasing, right? We haven't talked about transformations. This is something that we're going to hit on Monday, but I'm going to go over it just slightly. So for transformations, we always compare it to the parent function. The parent function is over here, which again, we're going to talk about on Monday. So how far did we move from this black dot right here to this black dot right here? How much did we go over? We went over 3 units. So we went to the right 3 and then down 4. Again, we're going to talk about that on Monday. So if you're like, what? It's okay. Now, increasing and decreasing, this is not changed from the last unit. So it's decreasing first from negative infinity to 3. And it's increasing from 3 to positive infinity. On your mastery check on Friday, you need to know how to do this box right here. Domain and range, and X and Y intercepts. Okay, those are the 3 little categories that you're going to need. Okay. Now, when it says pattern from the table, it's asking for the second difference. Okay, so the pattern from the table, I'm going to do it off to the side so it's not super bunched up. Okay, so from 0 to -3, how much of a difference is that? -3. And then from -3 to -4, how much of a difference? Okay, and -4 to -3, it's 1, right? And then from -3 to 0, that's add 3. So we see that the first difference is not the same. Good. The second difference is where we want to check. So from -3 to -1, how much? That's 2. From -1 to 1, that's 2. From 1 to 3, that's 2. Oh, I wrote 3. So this pattern from the table, it's a quadratic, and it's got a second difference of 2. Now, again, we're not going to talk about average rate of change yet. We're going to talk about that on Monday. Here's the graph of a function. Select all the values that are equal to 0. Okay, so what'd y'all pick? Let's see. Okay, so some of y'all picked A and C. Remember, A and C are your x-intercepts. Your y values are 0, right? Okay, on this one, E comma F, the E is your 0 value. Yeah. There's definitely one like this on your EOC. They like to give letters because it starts confusing people. Okay, don't be confused. Okay. All right, so on number 2, it says, here's the equation. Graph the x and y intercepts by entering their x coordinates in the table. Okay, so if I had 0, what value would that give me? If I had x equals 0, what would that give me? If I simplify it, it would give me -6, which is right here. That's our y-intercept, right? Now we want the y value to be 0 so we can graph our x-intercept. Look at this equation really quick. This is written in x-intercept form. Like it's in factored form. Okay, so really quick. Factored form looks like this. Okay. And if we want to find the x-intercept, all we're going to do is change the sign of this guy. Change the sign of this guy. So looking at our equation right here, what's the opposite of +2? Okay, so if I take -2 and plug it in, watch what happens. It gets 0. Boom, there's our x-intercept. Do the other one. What's the opposite of -3? Okay, plug it in. And then there's our graph. Cool. So for y-intercept, we plug in 0. For x-intercept, we set it equal to 0 or we switch the sign. This is what? Very similar to it, yeah. Yeah. Okay. All right, go ahead and go to slide number 3. Okay, on slide number 3, what do you notice about the x-intercepts? So what I want you to do is I want you to type out, how do you find x-intercepts? How do you find y-intercepts? So what we just went over. Take a second, try that one. All right. So let's go ahead and move on to the next one. So here's a new function. Graph the x and y intercepts by entering their x coordinates into the table. So if I plug in 0 in for x, okay, it graphs my y-intercept. So it's 0, 30, right? Here's the tricky part. If I want to find the x-intercept, this, we can't just switch the sign, okay? The reason why is because we've got that 2 filling out front in front of the x. So we're going to set this equal to 0 and solve. So if I were solving this equation, what would I do? I would add 6 on both sides. And then I'm going to divide by 2, right? So what does that give me? 3. But when I plug 3 into this equation, I get 0. And look, there's my x-intercept. Can you try finding this next one, though? Took like 30 seconds. All right, so what's x-intercept did you get? 5. Okay. On this one, we fortunately can just change the sign, but that's because we just have an x. We don't have a number and then an x out front. Looking at slide number 5, here's Raven's work from the previous challenge. She found an x-intercept at 5. She also says there's going to be an x-intercept at 6. What did she do wrong? What did she do wrong here? So she assumed, she assumed that we're just going to switch the sign, right? She didn't divide by 2. So she didn't actually solve for it. Okay, go ahead and take a moment. I want you to do slides 6, 7, 8, and 9. Yeah, 6, 7, 8, and 9. And then we're going to chat. So take about 10 minutes. Okay. So on slide number 6, what was your x-intercept? Actually, I'm just going to pull something else stuff. All right, so Gavin put 0, 1. And it looks like it didn't give you the correct answer. So with x-intercepts, remember our y value is 0, but our x value is a number. Okay, and we're going to find it by using these parentheses. So if we took this one right here, and we set that equal to 0, and we solved, what would be the first thing we did? We would subtract 8, and then we would divide by 4, right? So that would give us x equals -2. So when we type this in, we're going to say -2, 0. Cool. All right. On that other one, I'm going to take -x plus 0.5, and I'm going to solve. So I'm going to move that 0.5 to the other side. And then I'm going to divide by 1, -1. That'll give me x equals 0.5. So when I graph this, I'm going to get 0.5, 0. Yeah. Okay. Let's go ahead and look at slide number 7. Okay. On slide number 7, it said two students were asked to determine the x-intercepts. Yolanda says the x-intercepts are -2 and -9. And Julian says the x-intercepts are 0 and -9. So the majority of y'all did not get this one right. So let's look at it. Again, we're going to take each piece and set it equal to 0. So we've got 2x equal to 0 and x plus 9 equal to 0. Now this one we can just switch. And I see where both of y'all, or both of them have gotten that -9. So they already got this one right. But this one, what would I do in order to solve it? What would I do in order to solve this? Divide by 2. So x is going to equal 0. So it should have been Julian. Okay. All right, now here's the tricky part. On slide 8, this is in standard form. This is not in x-intercept form. Okay. So if we plugged in 0 into this equation, we can see that our y-intercept is going to be -10. Now, we need to figure out what this x-intercept is. Just take a guess. What would this x-intercept be? Maybe 2? And when we compute that, we get 0. So that's our x-intercept. What about this one? Take a guess at what this is going to be. If I took a guess, let's try -2. Well, that's not it. Let's try -4. That's not it. What if I tried -6? That's not it. What about -5? There it is. Okay. So it might take a couple minutes to try to figure out what that x-intercept is. Okay. Now, which were easier to determine on the previous slide? X-intercepts or y-intercepts? And why is that? Yeah. We just plug in 0 and boom, there it is. Excuse me. Thank you. All right. So what I want you to do is I want you to take these equations and I want you to match them up to the y-intercept. Okay, so you're just matching the y-intercept, not the x-intercept, just the y. So it's either going to be 0, -3 or 0, 5. Okay, take a couple of minutes. I want you to stop really quick. All right, so when you sorted these, I'm going to use Lawrence. Okay, so when you sorted these, if you look, all of these +5s, that's where we're going to get a y-intercept of 0, 5. All of these that are -3 on the end, that's where we're going to get 0, -3. But I do want you to note, like this one right here, it's not written in standard form, but since it has that constant, that +5, that's what's going to make that have a y-intercept of 5. Okay, good job. All right. Go ahead and jump to slide 12. Okay, and this is telling me, do you understand what's going on? Okay, so we've got the factored form, we got the standard form. What are the x and y intercepts of this function? Okay, so go ahead and take a moment. You've got the factored form, you have the standard form. Go ahead and tell me x and y intercepts. You got, okay, so you should, oh Lord, guys, come on. You're killing me. All right, so if I want to find my y-intercept, what am I going to do? You've got to know this. This doesn't go away. This is on your final. This is on your interim for the next quarter. I mean, like, you're going to see this. So let's go. What am I going to do? I've got standard form right here. What number am I going to plug in? 0. Yes. Okay. Or you could just look at this number that's at the end, whatever the constant is. So for my y-intercept, I'm going to have 0, -24. Okay. That's the easy one. Don't mess this one up. Okay. You can look at the standard equation. Boom, there it is. Okay. Now, x-intercepts where it gets a little tricky. Okay. You're going to look at the factored form. Here's the factored form. And you're going to take each one of these parentheses and set it equal to 0. So we're going to do that for both. Now, on this one, we can just switch the sign. We're going to subtract 4 and that's going to give us x equals -4. So we're going to have a x-intercept of -4, 0. Again, the easy part. This one, we're going to have to do a little bit of math, okay? So we're going to have to add 6 to both sides and then divide by 3. So that's going to give us 2, 0. I feel like maybe we struggle a little bit with solving equations. That might be a true statement. Like if I said, hey, here's an equation, solve it. Do we struggle a little bit? Okay. All right. So we're going to get a little bit of practice on that. Okay. All right. So what I'd like for you to do. All right. So we're going to just practice solving. So on your paper, I'd like you to write out 4x minus 16 equals 0. And I want you to solve for x. Seems pretty simple. So let's get the practice in. Okay. There's no reason why you shouldn't be good at this by the end of today. Okay. So solve for x, 4x minus 16 equals 0. Okay, back in like 6th grade, when you learned how to do this, and that's not a shame thing, that's just this is when you learned it. You learned about PEMDAS. When you solve, you do reverse PEMDAS. So you're going to add and subtract first. So you see this -16? I'm going to add it to the other side. I didn't do anything with this 4x, so I'm just going to bring that guy down. 0 plus 16 is 16. Moving on to the next letters in PEMDAS. Now you're going to multiply, divide. So you see that there's multiplication. In order to do the opposite of multiplication, we're going to divide. So what's 16 divided by 4? Okay. Boom. There it is. I want you to try this next one. Same setup. Okay. Take a second. Okay. So hopefully you added 25 first. And then you're going to divide by 5. 25 divided by 5 is 5. Everybody okay on that? Okay. Now I'm going to throw some negatives at you and a little bit of fractions. So let's do that one. Okay. Let me get a different color. I hate this red on here. Okay. So if I solve for x, and I have something like -x plus, let's do actually -2x plus, let's do 32. Okay, because I know negatives kind of trip us up a little bit. We're doing the exact same process. Okay, so we're going to add, subtract first. So we got this 32 chilling. We need to do the opposite to move it to the other side. So what is that going to be? Subtract 32. So this is going to give us -32 and -2x. Again, the next step is either multiplying or dividing. Well, we've got multiplication already, so we're going to do the opposite. We're going to divide. So that's going to give us x equals, and a negative divided by a negative makes a positive. So what's 32 divided by 2? 16. So x is going to equal +16. If you are ever unsure about the negative situation, just plug it into your calculator. Okay. All right, let's try one of these. Okay. You try -3x minus 18 equals 0. Okay, so the first thing that you're going to do is you're going to add 18. Okay, now we're going to divide by that -3. So this time, we have a positive divided by a negative. So we're going to keep that negative. We're going to have x equals -6. Questions about that one? Yep. Okay, because a negative times a negative equals a positive, right? And a negative times a positive equals a negative. Agreed? So if you have a positive divided by a negative, it should still be negative at the end. Yeah. It's kind of like if you do the reverse, you end up with a negative. Okay. I know it's a little tricky. Again, if you're ever unsure, use your calculator. Okay, let's try one more. This time we're doing fractions. Yay! No. Okay. Okay. So on this one, we got 1/2 x plus 20 equals 0. Don't get tripped up by the fractions. It's okay. We're all going to live. So first thing, we subtract 20. Okay. Back in like 6th, 7th grade, your teacher told you that if you have fractions and you're solving, you're going to do this keep, change, flip thing. All you need to do in order to get rid of a fraction is multiply by the reciprocal. So take the fraction and flip it. What number would that be? It'd be what? Flip this fraction. 2. So we're going to multiply by 2. So this will give me x equals -40. I don't have to do anything fancy. You just flip the fraction and multiply it by that to get rid of it. So let's try one of these. Let's do small number. Okay, try this one. You might get a little bit of a weird answer, but we'll work through it. Okay. So you added 4. Now, to get rid of the fraction, we're going to flip it and multiply by it. So what's the reciprocal of this guy? 2/3. Okay, now this is where everybody starts freaking out. When you multiply by a fraction, this cancels. And then 4 times 2 is what? 8. So we got 8 in the top. And in the bottom, we just have this 1, right? So 1 times 3 gives us 3. So this is x equals 8/3. If you type this into your calculator, you're going to get a decimal. That's fine. You can do it that way. But your answer choices are going to be in fraction form. Okay? Does that help anybody in this room? Fantastic. Okay. So now let's actually move on to the next part. So you're going to open up Desmos again. I'm sorry. It's like death by Desmos this week. I'm so sorry. This one's going to be a little bit quicker. Hopefully. Okay, so go ahead and join that one. Okay, so on this first slide, this will load. Cool. All right, if you hit zap, then it zaps right here, right? Now, if I want this x-intercept over here, what is that? It's 2, right? So we're going to say 2, 0. And zap. Okay, if we want this y-intercept, what's this y-intercept going to be? -4. 0, -4. Okay, when you do your mastery check, please don't give me some crazy like points. It's either -2, 0 or 0, -4. Like the x and the y-intercept really need to be defined. Don't just say what the number is. You need to put either the 0 at the end or 0 at the beginning. Okay. All right, let's go ahead and move to slide 2. All right. Can you figure out the x-intercepts from here. So we just did all that solving. You could be able to solve each one of these and then find the x-intercept. Take a second. Okay, so we just talked about this. So how do I solve this guy? Subtract 1. Boom. So x is going to equal -1. So when I write it, it's -1 comma 0. Let's try the next one. We got -x plus 3. We subtract 3. We've got a -x. You can't have that. You got to divide by -1. So x is going to equal 3. So we got 3 comma 0. We okay on that? Okay. Now, how would you find the y-intercept? So we got the x-intercept, but where's our y-intercept? So we got -1 comma 0. Okay. And we got 3 comma 0. Nope, JK. Yep. Now what's our y-intercept? So fun fact, if you actually multiplied this last bit, so what's 1 times 3? It would give me 3, right? That's actually our y-intercept. So if you multiplied this out, you could actually find that out, right? Okay. Now you could pick another point to fill this last part in, and that's going to be 2 comma, I think 3. So 2 comma 3 is up. Ta-da! Look at that beautifulness. Okay. All right, go ahead and skip to slide number 4. Okay, I want you to try to do 4, 5, and 6. Okay, take a second. All right. There we go. Okay. So on slide number 4, here are the x-intercepts. Drag the point to where the vertex could be. The vertex is always in between the x-intercepts. Okay, good. Y'all are fantastic. Look at y'all go. All right, slide number 5. Complete the parabola by adding its vertex. Well, the vertex has to be equidistant in here. So we know that it's got to be 3. It's probably going to be -3 here. So 3, -3. Zap. Ta-da. A little off. So it probably needs to go down a little bit, right? What if we made -5? Ta-da. A little off. Let's try -4. Ta-da. And it finishes it. Okay. All right. So tomorrow, mastery check over this stuff. If you're missing your interim or you're missing a test or whatever, let's go ahead and try to get that done by tomorrow. And then I'm doing your replacements for stuff today so that you can see it later on.